Good morning, everyone. Welcome back to the Development Research and Practice course. Before we get started and as people start joining, I just wanted to go over some housekeeping notes. All the links related to course materials, such as quizzes, reading lists, application questions, can be found at bit.ly/trip-overview. Avnish will send the link in the chat so that you can click on it if you need. And we share this also every week. Please remember to keep your participant ID safe and make sure you are using the correct ID to submit your quizzes. There's a single deadline for submitting all quizzes. That's September 1st at 11:59 Eastern time. You can track your progress using the course tracker at bit.ly/trip-tracker. Avnish will also send the links to that in the chat. So for those of you who don't know me, my name is Luisa. I am a junior data scientist at DIME, and I will be your instructor for this week and the next. Today, we'll be discussing Chapter 5 of the handbook, which is called Cleaning and Processing Research Data. So data cleaning, the task that we'll discuss today, is very time-consuming, and its task can be quite repetitive, so you may be tempted to rush through it. Here's the rub. Data cleaning mistakes can go unnoticed for a long time. And as I mentioned in my motivation slide, data cleaning takes around 60% of the time spent on data work. So you cannot afford to redo the whole task later on in your project if issues in data cleaning start affecting your results. This is why in this chapter, we'll discuss each step in the data cleaning process and outline a workflow that you can follow to set it up so you can be easily updated, adjusted, and reproduced. This is the workflow that you see in the image to the right. And before we get into the details of each of the steps in this figure, I just want to clarify that we separate them from one another for pedagogical purposes, but in practice, you will often be coding them and implementing them in your project at the same time. But what does it even mean to clean data? It means transforming the original data that you acquired into an appropriate format for the intended use. And there are two highlighted expressions here that I want us to understand. The first one is the intended use. What we intend to do with this data is to analyze it into statistical software. The other one is the appropriate format. During data cleaning, we will change the format of the data. So the clean data set will contain exactly the same information as the originally acquired data set. We will not, during data cleaning, add new variables or make significant changes to individual data points. The first step in data cleaning is what we call tidying data. Tidying is a concept borrowed from the database management literature and is probably new for most development researchers. So today, we'll spend most of the time making sure that everyone understands exactly what it means. So we have already said that clean data is in the ideal format to be analyzed by statistical software. But what format is that? Let's say, for example, that you have collected data on households, including on each member of the household. And you want to know the average age of all household members in your sample. If your data set looks like this, then in most statistical software, you will need to perform a series of operations before you can actually calculate this statistic. But fortunately, there's a vast literature in database management that has identified the format that makes interacting with the data more easy. In database management, this is called normalization, and when applied to statistics, we call the data in this format tidy. Tidy is the ideal format to handle data because it makes it easier to combine data tables, aggregate values, calculate statistics, and create analysis indicators. The first thing we need to understand when talking about tidy data is what is a unit of observation. We define a unit of observation as the entity or the entities that are described in our data. What they are exactly will depend on your study, and a single study may have multiple units of observation. So it could be a person, a household, a firm, a country, a city, a school, a classroom, and even a pixel. And this list can go on and on. It depends, really varies from one project to another. But let's look at an example so that we can start understanding what I'm talking about. And I see that someone has raised their hand. Please note that we will not use this feature during the seminars. If you have questions, please submit them through the Q&A box. Okay, so this data set that you see in your screen right now, it contains two different units of observation. And I'll give you 1 minute to take a look at this data and go to the Poll Everywhere link and tell me what are the two units of observation that you see here. Avnish has just sent the link to the Poll Everywhere question in the chat. I'll leave this this table here so you can look at it and think about the question. And in another 30 seconds, I will show you the results. Okay. So let's see, we have households, person, individual, and that is all correct. We have individuals and we have households. And a lot of people have said bicycle, gender, age. These are all things that we also see in the data set, but they are not units of observation. They are variables, and we will discuss what they mean later on. But as most of you have indicated, this data set contains indeed two units of observation. So we have household and household members or individuals. They're people that are part of this household. When we ask during the survey that is represented in this data table, does anyone in this household own a bicycle? We are measuring a characteristic of the household, of the collective of people that live in this place and share meals. When we ask each of the household members, each of the individuals that are part of this household, how old they are, we are measuring a characteristic at the level of the individual. And households and household members are two units of observations that are related, And we'll probably use both of them for analysis, but it's important for now that we are able to tell them apart, because this will help us process the information that we observed at each of these levels correctly. Okay, so now that we know what a unit of observation is, we can define a tidy data set. So a tabular data set, that is a data set that is organized by rows and columns, is said to be tidy when all variables in that table have the same unit of observation, when each column corresponds to one variable, and when each row corresponds to one observation. We'll get into more details about each of this criteria in a bit, but first let's look at another version of the same data set we already looked at. We know that the data set we saw earlier, that table, was not tidy because it had 2 units of observation. But what if we organized it like this? I will give you another minute to think about this and answer the question. But basically what I want to know is the data set that you see on your screen right now, is this data tidy? Okay, there's a lot of dissent among you about whether this data is tidy or not. Give it another 10 seconds for people to vote. Then I'm going to close this poll. So this data set is not tidy. As we saw earlier, the first condition that a data set needs to satisfy to be tidy is containing only 1 unit of observation. And whenever a data set does not has more than 1 unit of observation, then it will necessarily break one of the other 2 conditions for being a tidy data set. But let's look at the definitions of what are variables and observations so we can understand how this works. So a variable is the collection of all data points that measure the same attribute for each observation. So in this table that we saw earlier, oops, here it is, gender is a single attribute. Gender underscore 1 is not measuring a different thing from gender underscore 2. However, in the current format of this table, it is split into 2 different columns. That means this data set is not tidy. And observation, on the other hand, is the collection of all data points that measure attributes for the same instance of one of the unit of observation. So whenever I'm talking about the same individual, then that may be an individual person or an individual household, I am talking about the same observation. So if we change how we organize rows and columns in the data set, so that is in the last format we saw, we can see that age and gender are shown in a single column now. However, note that household 1978 is a single instance of the unit of observation household, as is household 1195. And in this version of the data table, these observations are repeated over several rows. So this means that in order to tidy this data set, we need to separate it into two data tables, one at the household level and one at the household member level. And each of these data tables will contain the variables that are measured at the unit of observation that it corresponds to. So in practice, this means that when you need to tidy your data, the first thing you're going to do is identify the units of observation. Sorry, I was reading a question here. So the first thing we need to do is identify the units of observations that are in your data set. And if the data set has more than one unit of observation, then we need to separate it into as many data tables as there are units of observation in our data set. Then, if those resulting data tables do not have a one-to-one correspondence between a variable and a column, and a row and an observation, then we will reshape it. So we will change what is present in a row and what is present in a column until each row represents one observation and each column represents one variable. So going back to the example that we saw earlier, in the case of the data set we saw that collects information about a household and about each of the individuals that live inside that household, this is what the tidy data set would look like. We have two separate data tables, and each one of them is at one level of observation and includes the variables that are measured at that level. I want you to pay particular attention to the first rows in each of these data tables. These represent the unique identifiers in the tables, and what they do is tell us how these two data sets relate to one another. So we know we can link the members that are the individuals in this data table to the households that are in this data table. And we'll talk more about unique identifiers soon as we discuss data quality checks. But first, I'm going to look at the Q&A box and see if we have any questions open. The second table does not have the same unit of observation in several rows. The second table, each row here is one member. So this table is representing one individual, and each row is one individual. So this is individual, let's say 1978-1, this is individual 1978-2, this is individual 1978-3. So we use this unique ID so that we can link these individuals back to this other data set, but they are still different observations. So next question says, according to the definition of tidy data, when we use combined data set by household data and household member data, the result data are not tidy. This means that it is possible to conduct the analysis with non-tidy data. Absolutely. Many times we will conduct the analysis on non-tidy data. Whenever we have our final analysis data set, it does not need to be tidy. And that is something that we will discuss next week. as we talk about data analysis. But yes, so if we were to analyze, to run analysis at the individual level, and we wanted to, for example, control our regression by characteristics of the household, then we would have an analysis data set that is not tidy. Someone else is asking, I'm wondering how this translates to panel data. I'm thinking of a situation where you have several countries over multiple years. What would each one need a unique ID given that they are the same observations? It's not very clear to me. So in a panel data set, the unit of observation is a combination of country and year. So let's say you observe Brazil in 2020, this is one observation, and Brazil in 2021 is a different observation. And then just like here, we have two different columns for the unique ID. We have household ID and then the member ID inside that household. We would have, let's say, year and country, and the unique ID would be a combination of those two variables. And since we are already talking about this, let me go to the next okay, sorry. Let me go to the next concept that I wanted to discuss with you all, which is implementing data quality check, because we'll discuss more about unique identifiers very soon. But first, let's get to what are data quality checks. So in this course, we are talking about empirical research. And empirical research results are only as trustworthy as the data that we use in it. If our data does not reflect the reality that we are trying to understand, then our results will not be as meaningful as we would like. And when we are acquiring new data and starting to look at it, we may find inconsistencies, ambiguities, and data entry mistakes. And inevitably, we'll have a lot of questions about the data that we just acquired. So when this happens, we should look at the data every time that we receive it, whenever we're acquiring data, because that will make it possible for us to collect more information to answer the questions that we have as they come up. If we wait, then it's possible that our field team will not be on the ground anymore. It's possible that the person that transferred us the data will have left the partnering institution that was transferring us the data. And there's a variety of reasons that may prevent us from being able to follow up on the questions that came up as we inspected the data. So there are a few checks that we want to perform as we acquire the data and every time we receive a new batch of data. The first thing we want to do is to make sure that we have a unique identifier. A unique identifier is a variable or a combination of variables, as we just discussed, that distinguishes each entity that is described in a data set at a given level of observation. So for each level of observation, for each unit of observation, we should have one unique identifier. And being uniquely identified means that we will have an ID variable that is never missing, and we can never have two different observations that have the same value for those ID variables. And many of the steps that we'll perform for the rest of our data work will depend on having a reliable ID variable. So for example, when we want to combine different data sets, or when we are running analysis and making sure that we are not giving a higher weight to some observations than others. So for example, in the case that we were just looking, I just got a question: when we are merging the two data sets, on what do we merge, the household ID or household ID and member? So we'll talk about merging next week, but in the case of these two data sets that we have here, notice that we don't have a household member in this data set. So we would not be able to use the household member variable to combine these two data sets. So we would have to use only the household ID. Now, apart from unique identifiers, the type of checks that we want to implement will vary a lot from one project to another. We have different kinds of data, we have different types of questions being asked. But we can, in a very high level, sorry, we can classify the different types of checks that we perform into 3 principles. The first of them is what we call completeness, and it means checking that all the information that we need for our research is actually included in the data that we acquired. So, if you received 50 observations, make sure that those are 50 different observations, that this is the number of observations that you expected to receive, and that they correspond to the observations that are in your sample. Then we have consistency, which means checking that the content of the data that you receive does not contradict itself, or does not contradict the previous knowledge about the context. So for example, if you are receiving information about children that are in primary in childcare, then you would not expect them to be 16-year-olds. This would contradict the context. And on the other hand, if you have someone that is unemployed, you would not expect them to have a wage. So this is the data contradicting itself. And finally, the last type of check that we want to make is looking at distributions. This means scrutinizing the data points in your data set to look for anomalies, and specifically to look for anomalies that may be caused by how the data was collected. So one very common example is that we often find outliers, and particularly in survey data, these may be coming from typos. So people just mistyped the answer, or also in survey data. So I'm going to give a lot of examples about survey data because that's what we have the most experience with in time. But it's possible that you have a lot of non-responses. So a lot of people that are saying, I don't know, or that prefer not to answer a question. And that may be, this very high number of non-responses may be due to how the enumerators are asking the question. So these are things that do not reflect accurately the reality on the ground. They are due to how the data was collected. Before we go to the next section, I will take another look at questions. Can the unique identifier be a string variable, or should it always be a numeric variable? I see that Chris is answered, but it can be a string variable. Depending on the software that you are using string variables may cause inaccuracies, but it's fine. You can use it if you prefer. I didn't, someone else says, I did not understand completeness. Can you please explain? I can explain. So when you're receiving data, the first thing you want to know is, did I receive all the data that I asked for? So let's say you are looking at a panel data set that someone mentioned earlier, and you want to have all the 2000 decades. So you want to go from 2000 to 2010. You want to make sure that all the years are there and that all the countries are there for every year, that you're not missing any type of information that should have been included in the data set. It's as simple as that. But oftentimes you may have, something that gets lost in translation, or by some mistake, you do not get the full data. So that's definitely something that you want to check. Okay, I see that someone has a follow-up question about working with secondary data, but I do not know what was the first question, so I will let whoever answered the first one reply. Okay, let's talk about processing confidential data. As researchers, we often have access to personal and sensitive information about our subjects. And we have already discussed in week 2 that this entails a responsibility to the privacy of the human subjects in our research. And we all committed to it. We all repeated 3 times that our time and our careers are not more important than the privacy of the humans participating in our research. So one of the practical implications of this ethical commitment is that confidential data must be handled within a secure environment. In practice, this means that the data will often be stored in an encrypted format that needs to be decrypted every time we interact with it. And encrypting and decrypting data is time-consuming and restricts access to the data. So in order to make our workflow more efficient, one thing that we can do is that we can maintain the original identified data securely stored, and then have another copy of that data that does not contain confidential information and that can be more easily accessible. And this other copy is what we call de-identified data. This is the copy that most of our team members will have access to, and that will be handled on a day-to-day basis. Now, I want to make a distinction here, because during this course, we'll discuss 2 types of de-identification. And what I'm talking about right now is what we call initial de-identification. This means removing the direct identifiers from the data set. That is, those variables that can be immediately used to identify a research subject, like GPS coordinates, names, and taxpayer numbers. Note, however, that removing this information does not mean that the data is anonymized. It's still possible to combine different variables in your data set and re-identify respondents. So the data set that has gone through initial de-identification should still be treated carefully and should only be shared inside the research team. Now, the reason we are talking about de-identification in this order in the presentation, so right after discussing data quality checks, is that oftentimes when performing data quality checks, we will need access to confidential data. So we may need someone's phone number so that if we need to confirm information, we can go back and check with them. But the principle to apply is that the data should be de-identified as early as possible in your workflow. So as soon as you do not need confidential information to be handled on a daily basis, then you remove that information from the data set that you are working with on a daily basis. So all of this is initial de-identification, but another more thorough round of de-identification will be performed before the data is publicly released, and we call that final de-identification. And Ben will discuss it in more detail with you during week 7 of this course. Now, this is all very good, but again, we're on this course focusing on how we do this in practice. And so here are the steps that you actually need to go through to de-identify your data. First of all, you will look at your original data and you identify the variables that you actually need for your research. When we are collecting primary data, we hopefully only collected variables that we needed. But when we are working with secondary data, then we may have received a lot of information that we'll not use on our research. So at this point in the data cleaning, we should not worry about dropping too many variables from the original data to the clean data, because the original data will still be there. And this is very important. We are not making changes directly to the original data. We are creating a different data set that is the clean data set. And we can always include more information from the original data set to the clean data set, because we have gone through all these steps that are outlined in this chapter, and we have made sure that our work is reproducible and that I can make just a little adjustment in my code to include another variable in my clean data set. However, if you had confidential information and that information was leaked, well, then you cannot go back on that. So we have our original data set, we identify all the variables that we will use for analysis. And then for each of them, we are gonna go through a little process. The first thing we're gonna check on that variable is, does it contain identifying information? Can it be used by itself to identify the people that are part of my research? If not, great, you just keep it in the clean data set exactly as it is. If it does, then we are gonna ask ourselves, well, what can I do so that I can still use this information without the whatever makes it confidential? So if I have the names of cities, can I just remove the name and instead use a code for it? Can I, if I have GPS locations, can I just use the distance to some place instead of the actual location? If that is possible, great. Then we'll keep the version that does not contain identified information in the clean data set, and we'll keep the confidential information with the original data in the encrypted format or whatever kind of data security process we're using. If, however, it is not possible to remove the identifying information and still use this data for analysis, then we're gonna have to put together a bit of a more complex workflow where all the analysis is performed in a secure environment, and how exactly that will happen will depend on the resources that your team has and the type of data that you are using. I'm gonna stop here to take a few more questions. I see that we have some. Does removing the names of enumerator, is removing the names of enumerators part of the identifying process? Yes, it is. So for one, you do not need the names of the enumerators for the analysis. I expect you need it for high frequency checks because you need to follow up and on question. But yes, the name of enumerator or of enumerators can be used to identify someone that was part of your research, not a research subject, but this is something that you should remove. and it's not, I think, needed for analysis. In the case of data with longitude and latitude, which may be necessary for spatial analysis, do we still need to encrypt the data since they seem to be PII? So that will depend on the kind of information that you're using, right? If you're collecting, I don't know, geospatial data on census tracts, this is not identifiable, right? You do not have a way to identify the people, hopefully, inside of your census tract. If you are collecting information on where a precise household lives, yes, this is confidential information. And you seem that you said that it may be necessary for spatial analysis, but in general, you don't need to know exactly where they live, right? You may need to know if they are close to someone else or if they are close to a particular location. And that information would probably not be confidential. So you can just use that way of removing confidential information from your data set. Is it possible to have a study population that is not well defined? How can samples be drawn from such population? For example, a survey that is targeting tax practitioners and others in a particular country, and the number of such professionals could not be objectively established. So this is more of a research question than about implementation. This will depend on how your study was designed, but you and I see that Ben is typing, and he probably has a better answer than I do. But yeah, you'd have to use some sampling process to identify who you want to collect data about. Are there any hands-on materials that you can recommend for about cleaning and merging survey data? Absolutely. So in our additional materials for this module, I have included sessions from our RA onboarding course that include hands-on material on tidying, de-identification, and data cleaning. In the Dime Wiki, we also have a checklist to make sure that your data set is clean. And we also have some more material from our managed successful impact evaluation and managed successful impact evaluation surveys. They are all available on the Open Science Framework platform. Someone else asked, sometimes we need the number of individuals to call back and get certain information. So my question is that the identification process is before or after data cleaning, and what is best practice? So that the identification process is part of data cleaning. You only need someone's number as you're performing data quality checks. If you need to confirm any information, you do not need that afterward. So as soon as you do not need that, you remove it from the data set. And from this question, I guess we get to the next point, which is what we are calling preparing data for analysis, and is what most people call data cleaning in our field, which means recoding, annotating, and documenting the data. So this is a task that everyone who has analyzed data in their life probably had to do so that it was possible to analyze the data. The main difference between what we recommend in this book and what is done most commonly is that this should be a systematic effort. That means that we make sure to inspect, document, and recode each variable in our data set. And we do this early on in the data work process so that we have a complete understanding of our data and it is ready for analysis when we started. So there are 4 main tasks in this step: exploring, correcting, recoding, and annotating the data. Let's go through each of them. So exploring the data means inspecting and describing the variables in your data set. Knowing your data set is what will make it possible to do analysis. And since data cleaning is the longest and most time-consuming task in data work, you should use this time to become familiar with the information that you have acquired. So take this opportunity to inspect each variable in your data set, understand their current format, and what is the best format to handle them in the software you are using, and to document their values and distributions. So for example, when you have continuous variables, you should summarize them, look at averages, standard deviations, minimum and maximum values, maybe do some scatter plots or density plots. When you have categorical variables, you want to have frequency tables for them, and maybe graphs or like bar graphs to understand what is the information that they contain. Then we have corrections. So if you perform data quality checks, you may have identified data entry mistakes, and you only want to change individual data points that you clearly and unambiguously identified as errors, and for which you know what is the correct value. This is the only case when you will make changes to individual data points in your original data, when you know them to be wrong and you know what is the right value. And even then, remember that you will not make changes to the original data. You will implement corrections through code and not manually edit the data set. So you have a complete record of all the changes that were made to the data set. And note also that this is done as part of the data cleaning. So these changes will only be reflected in the clean data set, not the original data set. The next step is recoding, which is what we call the process of changing how variables are stored and read by statistical software, so that whichever software you are using can best make use of that information. So examples of these are categorical variables that are sometimes imported into statistical software as text, but you want to convert them into whatever format your software reads them. So factors in R and labeled integers in Stata. And one thing to make sure while you do this is that the codes that we use for categorical variables are consistent. So for example, you do not want to have 2 variables indicating gender and one be coded as male and female, the other one be coded as man and woman, because then you will not be able to analyze this information together. Another common task that needs to be done at this point is to recode survey codes. So when we collect primary data, we often use negative numbers or very large numbers to represent don't know and prefer not to answer responses. We want to make sure these are turned into missing values so that they don't bias the analysis. And finally, there's what I call here annotation, which means making sure that your data set is as self-explanatory as possible. So whenever someone else is looking at your clean data, they don't need to look at a lot of different documents to understand what it says. So you should use whatever features and tools your preferred statistical software makes available to build in that metadata into your clean data set. And as you do each of these tasks, remember to document them. This is important for you to use the information as you do analysis, but also because possibly in a few months, you will not remember exactly everything that you did with your data and why. So remember to create a data dictionary that explains what are the definitions of each variable, what are their formats, what kind of information they contain. Remember to store all the summaries of the data that you created during exploration. You can look at them as you go through your analysis. And remember to take note of any anomalous points that you found that may bias your analysis, because then you can address them during data construction. This is something that we'll discuss next week. And finally, remember to have a clear documentation of what were the quality checks that you implemented, how errors were identified, and what was the process of correcting them. So you should never just replace a value. You should replace a value and say, I talked to the person that transferred me this data, and they confirmed that for this year, there was a problem that, and they used a different unit than every other year in our sample. So you want to have a very clear record of all the changes that you've made. And after you've done all of this, you will have 3 types of outputs from data cleaning. You'll have a clean data set that may contain 1 or more tidy data tables. You'll have the data cleaning code that created this data sets from your original data. So if you want to go back and redo everything, you can just use that code. And you have documentation that clearly records everything that you did and why. We have 10 more minutes left. I'll take that time to answer questions. I see that we have quite a few on the Q&A box. First one, the book mentioned using extended missing values. Could you please elaborate on this a bit? Yes, so extended missing values are a feature of the Stata software. And when a value represents a non-response or a lack of information, it can be recorded as a dot or dot and something else, like dot A, dot B, dot C. So whenever you have a non-response, you don't have exactly the information that you wanted, but having a non-response that says, I don't know, or that says, I prefer not to answer, is some sort of information, right? You know something more than just, I have no information about this variable. So when you use extended missing values, you are kind of making sure to keep that small bit of information in your data set. So you would transform, let's say, if all I don't know were coded in your surveys as -8, that's what my team uses, then you will replace them with .d, which means I don't know. And it's different from this question is not relevant, or this person knows the value, but they prefer not to tell us. And I know that R also has a package that allows you to use some sort of extended missing values, but I've never actually used it. But this is what you would do in Stata. Other very important question, is a data dictionary synonymous with a codebook? Not exactly, but you can kind of put them together. A data dictionary is a list of variables and then their definitions, so what you use. Then a codebook usually involves some more information about the data, like its distribution, the values it contains. But yes, you can absolutely put them together in a single piece of information, and ideally you should do that, because that makes it a lot easier to find information about your data set. But yeah, so basically when in the slide that I had that says have information about the format and the definition and the distribution of your variables, if you can put them, all of that in one document, that is amazing. We know how data and code looks like. What about the documentation? Can it be Word, PDF, Excel documents? What do you advise as good practices? Well, it can be, it can be Word, Excel, PDF, all of those. It can also be a website, let's say a GitHub repository that has the information. There's not necessarily a best format for it. Good practices that I would suggest, and guys, Chris, Ben, Avnish, please feel free to jump in if you want to add anything. I would advise that it be as concise as possible, so that if you can have a single document and only one format, only in one place, that is good practice, so that you can find information as easily as possible. There is also a very nice README template from the social science editors. I'm going to look for it, and it basically lists a lot of documentation that you should include about your code. I think we actually will discuss this next week, so I'll send you the link then, but this is a really good template that I like. Someone has asked, what is the difference between analysis do file and construction do file? According to your explanation, cleaning and construction of new variables are done at the same time. Absolutely not. They are not done at the same time. When you're doing data cleaning, you are not changing the information that you receive. You are only changing its format. So you are not adding new variables. And I guess one exception to that could be during the identification, but you should not construct new variables, new indicators during data cleaning. This is what we call construction, and this will be discussed next week as part of the analysis, because this is not about, measuring observable characteristics in the world. It's about creating research abstraction based on those characteristics, and this is part of research. This is like what we classify as part of data analysis. So we'll discuss that next week. Do you still recommend working in Git during tidying and recoding? Absolutely, yes. You are writing code to tidy and recode your data. This code should be version controlled in GitHub. You can also document it on GitHub. It's great. You can use the wiki feature. You can use issues. You can use README files to document your work on GitHub. Absolutely, everything from as early as you start handling data and code, you start using GitHub. What's next? Could you please re-explain answer to when you're dealing with longitude and latitudes? Do we still need to encrypt the data since they seem to be PII? The answer is yes, it's PII, you need to encrypt it. But the point is that it may not be necessary in this format for data analysis, right? You may just need distances or know whether a household is located inside a particular village. So it's very rare that you'll actually need GPS coordinates for your analysis. You need to, to use some derived indicator for that. Okay, we have 1 more minute and no more questions. So unless there's any literally last minute questions, we'll wrap it up over here. And I will be your instructor again next week. We'll be discussing construction and analysis of research indicators. So if you have any questions, we are all available through Slack, and we are monitoring it and try to respond as fast as we can. Someone has sent the last question that I will answer, and it is, what is a follow-up survey? And a follow-up survey is, you know, a second round of surveying the same people. So when you're doing impact evaluation, for example, you typically collect a baseline survey that is to know how people were originally and what was the baseline values of our research data, and then we do another one. We follow up and re-interview the same people to know how they are later in time. Okay, thank you, everyone. I'll see you all next week. Bye-bye.